In order to find the shear strain at each corner of the deformed square shown by the dashed line at position A, B, C, and D relative to the XY axis, where the side D dash and B dash remain horizontal, we can start by defining what shear strain is. Since shear strain is caused by the angular deformation or the change in angle due to shear stresses applied on an object, so basically we need to identify the change in angle from the initial internal 90 degrees of the edges of a square. What are the new angles? The difference in these angles will give us our shear strain value. So starting at point A, since we know that the internal angle between the edge AD and AC is 90 degree, and the new angle is formed is 91.5 degree. The difference between them is negative 1.5 degree. Now shear strain needs to be represented in radians, so we need to convert it from degrees to radian, and we can do that by multiplying it with pi over 180. Simplifying, we get the value of shear strain at point A relative to xy axis as negative 0.0262 radians. Next, let's move to point D and figure out what is the shear strain happening here. Now, in this case, I can draw a right angle triangle from point D dash all the way to point A, and from point A move vertically upwards to drawing the dash line going horizontally from D dash to make a right angle triangle. Now we are doing that so that we can calculate the new internal angle point D is making. Since one of the angle is 1.5 degree, where the second angle is the right angle, so the third angle can be calculated by subtracting these two from 180 degrees. That is coming as 88.5 degrees. Now, once we have the new internal angle, we now have to figure out the change or the difference in the angle that is formed. Now, one thing to keep in mind, since we are calculating relative to the xy axis, so we want to make sure that we are measuring all the angles from the positive x-axis in the counterclockwise direction. To do that, we can place our axis on the new point at D dash and start measuring the dotted line. So this angle will be equals to 360 minus 88.5, that is coming as 271.5 degrees. Now this is the new angle. The initial angle at point D, again relative to the x and y axis, is equals to 270 degrees. Now since we are looking for the shear strain, that is a difference between these angles, so 270 minus 271.5 degrees gives us again a value of negative 1.5 degrees. Multiplying it with pi over 180 give us the value in radians. Now, one thing to point out here about the sign convention: whenever the angle increases from its initial value, the shear strain value is given as negative, whereas whenever an angle decreases, then it is taken as positive. This is just the sign convention of representing shear strain. Next, let's go ahead and identify the shear strain at point C. To do that, we have to calculate the new internal angle at the corner C dash given by the variable theta here on the figure. Now, in order to find this angle theta, let's develop our right angle triangle by dropping a line down from point B dash. Now the base of this right angle triangle is equals to the sum of 8 millimeters and 3 millimeters as shown on the figure, whereas the perpendicular distance, we don't know that value yet. However, we are provided the information that the side D dash and B dash remains horizontal, which means that if I draw a line from the horizontal dash D dash B dash line towards x-axis, that distance will be equals to the perpendicular of our right angle triangle. Now to do that, we can form an additional right angle triangle, this time in between point D dash A and this new vertical line that we have just developed. Now, since we know the distance between point D dash and A as 53 millimeters, and the angle between this line and the vertical line is 1.5 degrees. So we can calculate the value of this vertical line given by the variable x by taking the cos function. So this distance will be equals to 53 cos 1.5. Now this distance is identical to the perpendicular of our first right angle triangle. So we can apply our tangent formula, that tangent theta is equals to perpendicular over the base of the right angle triangle. Simplifying, we can calculate our value of theta, that is coming as 78.27 degrees. Now the initial angle was 90 degrees, whereas the new angle that is forming with respect to xy axis, measuring from the positive x-axis going in counterclockwise direction, is equals to 180 degrees minus 78.27, that is 101.73. Taking the difference between 90 and 101.73, we get the value of negative 11.73. Multiplying it with pi over 180 give us our value in radian as negative 0.205. Now finally, let's go ahead and solve for our corner B. Again, we can calculate the internal angle, since we know that the sum of internal angles will be equals to 360, subtracting the other three internal angles of 91.5, 88.5, and 78.27, we can get the fourth internal angle, that is coming as 101.73. Once we have the internal angle, again we have to figure out the change in angle with respect to the x and y axis. So let's draw the initial point shown as B and the new deform point as B dash. Again, we will place our xy axis on the point itself and measure the dotted line with respect to our x-axis going in the counterclockwise direction. So the new angle it is forming is 180 plus 101.73, that is equals to 281.73, whereas the initial angle with respect to positive xy axis was 270 degrees. Subtracting it from the initial one, we get a value of negative 11.73. Again, multiplying it with pi over 180 to convert from degrees to radians, we get our final value of negative 0.205 radians.